Welcome to Circuit Analysis. I'm Jesse. In a previous video we talked about how to automatically set parts values using scripts, and in this video I want to talk about how to set parameters, as they're called in SIMetrix, or variables in SIMPLIS. So there's a few different ways to do this, and there's probably some more that I haven't thought of, but the very most basic way would probably be to not even use SIMetrix SIMPLIS. And what I mean by that is, if you look here, I have the two ways of running a simulation. This top one is for SIMetrix and this bottom one is for SIMPLIS. So if you recall with the SIMetrix version, you just call the netlist function and you give it a file name is the first step, and then you call the run function on that netlist. And the SIMPLIS one's pretty much the same, except you have this pre-processed step before the run. And since those are separate steps, what you could do is you could do the netlist, and then between there and the run you could open up this netlist file you generated and you could modify it. So that's one way that you could inject parameters, or you could really change whatever you want external to SIMetrix SIMPLIS or using the scripting language. Side note, this exit script here is pretty useful if you want to debug your code for just running the first part of your code, and it'll stop when it reaches that. So another thing you can do, if we go to help, PDF manuals, in the script reference manual, and you look up the run function, a trick you can do is if you do Control F, you can search for the name of the function, a space, and then the opening bracket, and sometimes that'll help you find it faster. And that has an option here, extra lines, that you can use. So when you call run, you can add some lines into it that will be added to the netlist. That only works in SIMetrix, however, because SIMPLIS uses the run SIMPLIS command, which doesn't have that option. So another thing you can do is use the F11 window. So if we go back to here and we press the F11 key on the keyboard, and that brings up this window, which is injected into the netlist, and you can write stuff in here. So one thing you can put in here is include files. So you can write dot include, and then you can put file name dot text, for example. You can make a file in the directory, project directory, named file name.txt, and then it will add that into the netlist. So then you could use a script to automatically generate this file and change it between each simulation. But another thing you could do is just directly inject text into this F11 window. So we'll try that. So first what we're going to do is we're going to set this up in SIMetrix mode. So right now we're in SIMPLIS, we'll switch to SIMetrix mode, and I'm just going to delete all of this. This is actually where you set up the simulation. So I'm going to go back here to simulator, choose analysis, and I'm going to choose a transient analysis for 1 millisecond. And now you can see that set up the simulation in the netlist. And now what I want to do is go through here, and I'm going to change all of these to take parameters in. And remember, in SIMetrix it's parameters, and in SIMPLIS it's variables. So to change these, you can click on it, and you'll notice if you double click on it you can put in values, but you can't put variables in here. If I try and type a bracket and I can say V1, it won't let me do it. Like when I type a V, nothing happens. So let's cancel that. The way that you can directly change the value on this, you press Shift and then F7. And that pops up this little box where it lets you directly enter the value. So you can put an expression. So we'll put open bracket, and let's just call all these with a parameter that's the same name as the part. So we'll call it V1. And we haven't made these parameters yet, we're just setting it up. So we'll click Shift F7, R1, and here, Shift F7, we have to be a little careful on this one because it has this initial condition. So what we want to do is just leave the initial condition there, and we'll put this C1 variable in here. And now we can bust out our spreadsheet. So I've made this spreadsheet, and arbitrarily I've put the parts on the rows here, and then I've created these different cases, 1, 2, and 3 in the columns. And so what we want to do is run each case as a separate simulation. So to do that, we need to convert these into parameters that we're going to inject into the netlist. So we can go down here and just put, these will be the same, these are just labels. So we'll get our 3 cases. I'm doing Control R to copy to the right. And then here, what we want to put is equals, and we're going to type dot, because this is SIMetrix, we're going to do param, and then we're going to say space, and then the name of our, we're going to use and to concatenate. The name of our variable is this v1 here, and we're going to say and again, and equals, and then the value. So the value is going to be this one up here. And now this is the string that we want to put into the netlist. So if we go up here, we can put a $sign in front of this one, which will fix our column for these. And now when we copy this, I'm doing Shift and right, and then Control R to copy to the right. So now it'll copy these to the right, and it'll keep the blue one highlighted for each one of them, because we put the $sign in front of the A. Now we can copy all of these and Control D to copy down, and make these a little bigger. Now we can copy this whole thing, and we can make a text file. Here's a new text file I've made called cases.txt in the project directory. We can paste this in there, so it's now been tab delimited, because when you copy from Excel, it puts tabs between the cells. So we're going to save that. And now we just have to write a script that will copy each column from that text file into the F11 window and run a simulation. And I've gone ahead and just written the script, so I'll just go over it, and so you don't have to watch me type every single line. But so what it does here is we're just echoing start, so we're just going to write that in the screen over here. And then this part is the same as in the previous scripts, where we're just getting a variable with the path to the local project directory. And then here we're saying file name equals that path and cases.txt, which is the text file that we just made. And then we're reading the file with read file, and we're getting this lines variable, which is an array for each line. And then we have column count equals 3, and that's because we have 3 columns here, case 1, 2, and 3. And then F11 rows to keep 20. What that does is, if we go back to the F11 window here, we don't actually need to keep 20. We just need to keep these 3 here. But what we're going to do is just keep a bunch of the first rows and then paste the new rows down here so that we don't overwrite what we already have. and then we're going to say let tab equal escape string /t, and that saves the tab character in this variable, so it's easy for us to make tab characters. And then we're looping here for C, which is the column. C equals 1 to the column count. And we're going to get the run title. So the run title is going to just be what's in the first row of the text file, so case 1, 2, and 3. That equals select columns, line 0, that's the first row, C, and then the tab character because it's delimited by tabs. And then we're going to echo run and then the title, and that puts it in the command shell. And then we're going to let this variable flines be this function get F11 lines, which returns all the lines in the F11 window that are currently there. And then for R equals F11 rows to keep to F11 rows to keep plus the length of the lines from the file -2. And the -2 is because we have this top row already, and then we also -1 more because we're starting at 0. Then this let f lines over here R equals select columns lines R minus F11 rows keep +1 C tab. What that's doing is it's taking the file that we're reading, the column from that file, and it's adding it to the F11 lines that we read up here, but it's starting at R, which starts at F11 rows keep, which is 20. So we're keeping everything before 20, and then we're overriding starting at 20 with what's in the text file. And now we're overriding the F11 lines here with this array of new F lines, and we're passing the result from that to this success variable because that it returns whether or not it succeeds. And so then we can echo F11 success here, and it'll say success or failed. And then we just do the run here, run the create the netlist, pre-process the netlist, and then run SIMPLIS. And then that will loop for each column. So if we run this, we can click the play button, and we're getting this error. It says index out of range. And that's because of this little comment here. It says note, must make a bunch of extra lines in the F11 window. So if we go over here, there's only 4 lines. So what it's getting is 4 lines, and then it's trying to start at line 20 and add new lines, but there's no lines past 4, so it fails to find line 20. So we can just hit enter a whole bunch here, and we'll just put some new lines. We'll put it down to 30 just to make sure we have plenty of new lines. We can save that and then go back to here and try again. And so now we have another error. So it looks like it got confused because what we're trying to do is run the SIMPLIS version, but we have everything else set up in SIMetrix. So what we need to do is just copy this code here to run in SIMetrix. There we go. Now when we run, we get the 3 curves. And if we press F11, here's the schematic, and we can see we have our parameters pasted in here. Now we just ran 3 cases with different parameters, and what I want to show you next is how you can run those cases all at once using multiple cores. But unfortunately it only works in SIMPLIS as far as I figured out so far. So we are going to go simulator, switch to SIMPLIS mode, and then we'll go simulator, choose analysis, Actually, first, let's just get rid of all this stuff here. And we can go Simulator, choose Analysis. And we can do a transient analysis. And then that'll put stuff back here for SIMPLIS. And we can go Simulator, Setup Multistep. And what we want to do here is we're going to use the multi-step analysis because it has this multi-core feature where you can tell it to use 4 cores at once. And we're going to step starting at 1 and we're going to go to 3, and that's for our 3 cases that we just ran. So there's 3 steps, and we're going to give it a parameter name of just run. So it'll do run 1, run 2, and run 3. We'll say OK. And now down here we can write if statements. So SIMPLIS lets you write if statements if you do .if, and then we can say the variable, that run variable we just made for the multi-step, we can say run equals, you can do 1 or 2 equals 1, and then you say .end if. And we can do is we can copy and paste that for runs 2 and 3. And then we can go back to our spreadsheet. We can get our params here. And we can just paste them in these if statements. But since it's SIMPLIS, we have to turn the params into vars. Okay, so now we have if run equals 1, we're going to use these variables, and if it's 2, we're going to use these, and if it's 3, we're going to use these. So we can run our cases all at once now when we go simulator run multi-step. And now we have all 3 of our curves again. It didn't really look that much faster because it's such a simple circuit, but if you have a complicated circuit, you'll definitely notice the difference. And now you can do other types of analysis with this technique. For example, let's try a sensitivity analysis. So for that, I've made another sheet here and I put in some values. And a sensitivity analysis is where you have tolerances on all your parts. So here I've made these columns where you have a nominal value for each part, and you have a minimum, beginning of life minimum, beginning of life max, end of life minimum, and end of life max. So for our sensitivity, let's set everything to nominal, and then we'll run one simulation for each part. So we'll start with everything at nominal, and we'll set V1 to its EOL max, and then we'll set everything to nominal again, and then we'll set R1 to its EOL max, and so on, so we can see what the deviation of the output voltage is for each part changed to its max. So for this we're going to use if-else statements. So we're going to say if it's run 1, we'll set V1 to its EOL max, else we'll set it to the nominal. So everything will get the else nominal unless it's the run for its turn. And we could just do this manually, just writing if-thens, because we only have a couple. Or we could do Excel formulas to write them for us in here and just copy them down. But since we're doing SIMetrix SIMPLIS, let's write a script that converts these into the if-then statements that we need to paste in the F11 window. So we'll make a new text file in the project directory, and we'll call it tols2.txt, and then we can get these values from our spreadsheet, copy them, and paste them in here. and save that. And now I went ahead and wrote a script that loads in that file and puts out another text file that has the if-then statements. So I'll just go over that so you don't have to watch me retype the whole thing. So first it echoes start, so just print start out, and then it saves these 3 characters that are hard to write in the code. So the first is the tab character, and the second is the open bracket, that's the squiggly one like this, and then the close bracket, this one. And then we have our directories, so we're just getting the path to the project, and we're writing variables for our input and output file names. So our input file is the script directory concatenated with tals2.txt. That's that file that we just created here with the parts values. And then our output file we'll call multisenseout.txt. And here is our lines we're reading in from the input file. And then this is getting our headers, the first row, splitting them by tabs, and then using that to get index values of the columns for the reference, prop, nom, EOL max. We're not really using the prop for anything, but here we're getting our ref des list from the first column, from the ref index column. And then we're initializing our output text to be an empty string. And here is the loop, so we're looping through each of the rows of the parts in the file. And we're using I to loop, and we're looping the length of the ref des list -1 because we're skipping the first row, which is the header row here that just has the titles. And then we're getting for each row the ref val, the nom val, and the max val from the ref index, nom index, and the max index. Those are the column indices. And then we're letting our output text equal our output text, so we're adding to the text, and we're concatenating onto it dot if, so this is the if statement, and the parenthesis current run equals I, so it's going to start with 1, close bracket, new line, tab, dot var, the reference designator equals the value, new line, else, new line, tab, dot var, value equals the nominal value, end if with some new lines. So then we output that text variable that we've created with /plain/file out file name, and then the output text variable. So it's just going to put this variable into a plain output text file with the name coming from up here, this multisenseout.txt, and then we'll print end. So if we run that, we just get start end, so it ran. And if we go over here, we have a multisenseout file, and here it is. So it wrote if current run equals 1, v1 is 11, else v1 is 10, and so on for each part. So now we can just copy this, and we can go back over here and paste that in place of this other stuff. And we save that. And then we can do simulator, run multistep. And that actually did not do anything because our variable's name is run and this one is current run. So the easiest way to change that is simulator, choose analysis, now set up multistep. And we're going to change this to cur run for current run. And then we'll run that. Now we can see our 3 different runs. And if we close this, because we have them on top of each other now, we can run multistep. And there, now we have just those 3. And if you want to see where the green curve is, you can hide the blue curve. And the green curve's right underneath it. And that's because these values were both changing by 10%, so they ended up canceling each other out and being on top of each other. So now we have 3 cases with the max value, but what we forgot to get was the nominal value. So at this point, what we can do is we can just, since there's only a couple, we can just add 1 to all these. 2 will become 3, and 3 will become 4. And then the very first time that it goes through, it will just hit else on all of them, and so they'll all be the nominal value. So we can save that, and we can go to simulator, set up multistep, and we can change this to stop at 4. And we can run that. So now we have 4 cases where the first one is the nominal case and then the last 3 are the sensitivities. So now that we have this array of multi-step curves, we need to loop through them with some code to get whatever parameters from them we want so we can calculate our sensitivities. So we can write a script for that, or might have guessed I already wrote a script for that, and we can go through that real quick here. So you start off here echoing start, and then you have a couple input parameters. I like to put input parameters at the top so that you can just change things at the top of the file when your data changes. So the first thing is the param formula variable, and this is sort of a, it's kind of tough with this language to figure out what exactly is a string and when you use single quotes or double quotes or brackets. But the way this is going to work is you can actually put in single quotes a formula, and then you can have it evaluated in a parentheses later. So like down here, we're evaluating that formula. And it doesn't matter right now that I doesn't exist here. So if we took away the single quotes, then this would just try and evaluate this curve and store the actual data into this variable. But since we put the single quotes, it's just a formula that can be evaluated later. So then we have the output file name. We're going to save a file called multirundata.txt, and we're going to tell it that we have 3 parameters that we're looking at. That's for our loop. So here we just do our standard get the current directory deal, and then we have file name is the current directory and tols2.txt. So that's that text file that has the parameters that we made earlier. And what we're going to do is just load that file in, and we're just going to add a couple columns on to the end of it to give us our sensitivity. So then we let lines equal read file file name. So we're reading in that tols file. And now is when we're going to get our first, use our formula to get our first parameter, which is our nominal value. And so our formula right now is just to get the maximum. And then we have v out I. And we have this hashtag # here because that's what you use for SIMPLIS. And v out is our this node right here, the V out that we've been measuring. So down here, the nom-param variable, we'll call it, is going to be the evaluation, because we put the squiggly brackets around it, of this formula up here. So that's the nominal value. And then here we have output text is 2 slashes makes a new line. And then we're going to print nominal colon, and then we're going to evaluate the value because of the squiggly brackets of this nom-param that we just calculated. So we're saving that, and then output text, under that we're going to put these header files. So output text, and we're concatenating onto it escape string. Escape string converts special characters that you can't write, like tabs, into the tab character. So if you write /t, it makes a tab when it's in this escape string function. So we're saying ref tab prop tab nom tab bol min tab bol max tab eol min eol max dir and sensitivity. So these are the two columns we're adding. And dir is just going to be direction. It's going to be a plus or minus. And then sensitivity is going to be the percentage difference when you go from the EOL max to the nominal value. So here's our loop. We're going to loop through the 3 parameters. So num params here, which we've set to 3. And we're going to let max params equal the param formula. So right now we're doing I equals 1. That's our first run here for V1 being set to the max value. And then here we'll just echo these out to the command shell. You can see I've already run it a couple times over here. And then we'll let sensit is the sensitivity variable equal the max minus the nominal divided by the nominal. So that's our sensitivity calculation. And then we'll say we're going to set the sensitivity based on whether or not we want to give it a plus or a minus. We're checking if max param is bigger than the nominal param. If it is, then we're going to write this line to the output text. It's output, we're adding onto the output text lines I, so that's the current line that we read in from the text file. And we're using the escape string so we can convert these slash characters into tabs. And we're going to put a plus right here. So this is our dir direction column. And then this here is format number. This is a function. We're going to format our sensitivity variable to be to 2 decimal places and have a % after it. So then otherwise, if it's smaller than the nominal, once we've set it to the max, then we know that its direction is minus, and then we have the sensitivity the same. So then when we're done, we will have looped through all 3 of those, and we'll output in plain text this output file with this output text, and then we'll say finished. So we can click play and run that, and you can see here it runs again and it gets these values here. And now if we go over to our working directory, we have this multirundata.txt file, and this has that other file plus it has this nominal value here, and then it has the direction and the sensitivity column. So we can do Control A, Control C, and we can get our Excel sheet and we can paste it up here. Now it's easier to look at, and we have it in Excel. So we have our nominal value of 9.93, and then we have here just this stuff copied that we had before down here, but we've added onto it these two columns, this DIR and this sensitivity. So we have V1, when we increase that, it's positive influence on the output voltage, and then R1 and C1 have negative. As we increase those, they make the output lower. And V1 is 10%, and then these two are negative, around 0.4%. So that concludes a few different ways to use scripts in the F11 window to help automate your analyses. Thanks for watching.